All right, so this is one of my favorite limit questions because usually when you're asked to evaluate limits, you use algebra or there's another, you know, algebraic method for reducing things. Now for this one, there is no such algebraic method, at least not a simple one. And so the first thing we always try and do is plug in the actual value. So plug in x equals to infinity, and what do we get? Well, as x goes to infinity here, this value gets closer and closer to 0. So inside the brackets, it becomes something that's approaching 1 plus 0. So that's just 1, right? So this is going towards 1. And the exponent, as x goes to infinity, is obviously exploding off towards infinity. So this thing's going towards 1, and this thing's going to infinity. And the question is, does this go to 1 fast enough? Because if this becomes 1 fast enough, then it doesn't matter what happens in the exponent. But if this takes its time while it goes to 1, then this exploding exponent will explode the value in total off to infinity. So we don't actually know what happens here. We have to recognize that this is actually the definition of the exponential. So if we click walk through here, you'll see that here's the definition of the exponential, of the term e, the constant e. Its limit as x goes to infinity of almost that exact same thing from the question. It's 1 plus k over x to the exponent x. That's the definition of e to the k. So if it was like e to the 3, for example, then k would be a 3 here. So if you're finding this video helpful so far, I'll just pause really briefly to ask you to support the channel. Please hit subscribe, please hit like, and leave a comment if you feel like it. Thank you. Okay, so back to this. We have to manipulate our question so that we can expose this definition. So here was the original question, and it's not quite in that form that we need. We need it to be almost exactly in that form. But what we can do is we can factor out the 3 from this exponent here. And when we do that, we reveal something that's much closer. Now the question is, we have this 3, which is an exponent of this thing here, and the limit is outside. The question is, are we allowed to bring this square bracket on the other side of this limit as well? And because of the properties of limits, yes, you can. You can do that. Those things are equivalent, those lines. So this line here is equal to this line up here. So we're allowed to do that. Now this is just the definition of e to the 4. And so that's what we get. So we get the inside stuff is e to the 4, and then we have to apply the 3 out there as well. So that's it. I hope you enjoyed it. You can click through. This is in Math 140 and 141. It'll probably also be in Math 122 for McGill. So just on the home page, you can click on any of these courses. Right now it's just in 140 and 141, and you'll find it under the definition of